Welcome to Study Loop.
Once again, we have a new problem. So this time we have a Prius. Okay, we have a Prius with the weight. The weight of the Prius is giving us 3,000. Let's change that a little bit. So the Prius is moving northwards and it's driving northwards that way. And the weight of the Prius is giving us 3,042 pounds. We want to change that right away to kilograms. So we multiply that by 1 kilogram per 2.2 pounds. And that's going to give us 3042 divided by 2.2, 1382.73 kilograms. That's the mass in the mass of the Prius together with the driver inside of it. The weight of the driver inside of the Prius is given as 150 pounds. That's the information we're given. There's a Dodge Durango that's traveling eastward. So this is east and this is north. This is north. And the weight of the Durango is 6,500 pounds. And so we want to get the mass of that. We multiply that by 6,500 pounds times 1 kilogram over 2.2 pounds. And that gives us 6,500 divided by 2.2 pounds. It's rounded off, so 2954. Okay, 2954 kilograms. Okay, that's what's happening. And then also they're going to collide with each other, make an angle of 39 degrees. So let's call that theta. Theta equals to 39 degrees. There's a final velocity for the Durango and the Prius. And that final velocity can be split into two components, the final in the x, and also you have a final in the y direction. Also, there's an initial velocity for the Prius, which is 50 miles per hour, but we want to change that right away to meters per second. So we can multiply that by times 1 times 0.447 meters per second over 1. So 50 times 0.447, it gives us 22.35 meters per second. The velocity in the y direction for the Prius is exactly the same as its own velocity because it doesn't have any x component. The velocity in the x direction is given us 0 meters per second. When it comes to the Durango, the initial velocity of the Durango in the y direction, you can see 0 meters per second since it's not moving in the y direction. The initial velocity in the x direction, we don't know what that is, and that's exactly the same as its regular velocity. So as part of the problem, we want to find, this is part A. Okay, so part A, we want to find the Durango's speed before collision. It's moving in the x, so its speed is exactly the same as its x component. That's part A. Part B, we want to find the final velocity of the Prius and the Dodge when they collide. So this one right here, there's a tree right there before they collide. So that's how we're running the problem. There are multiple components to this problem. Always think about it in terms of x and y direction. So going to the second part, the initial momentum of the Prius in the y direction equals to the initial momentum of the Prius. So now let's start with the y direction. Okay, so we're gonna do the y direction, and then we'll deal with the x direction afterwards. So the using the law of conservation of momentum. This is the y direction. So the initial momentum in the y for the Prius plus the initial momentum, I would call this pi. The initial momentum of the Durango also in the y direction equals to the final momentum of the Prius and the Durango in the y direction. So that's how it's given. And so this is the mass of the Prius times the velocity of the Prius in the y, the initial velocity of the Prius in the y, the mass of the Durango times the initial velocity of the Durango in the y direction equals to the mass of the we're combining the Durango and the Prius because they're colliding, but this is in the y direction. Their mass together, and also their final velocity in the y direction. So this is the final velocity in the y direction. So we gotta be careful. Final in the y direction. That's how we have it. Going back, we see that the initial velocity of the initial velocity of the Durango in the y direction is 0. So this is all going to be 0. And we want to find the final velocity of the Durango in the y direction. So this is the final velocity of the Durango and the Prius in the y direction equals to the mass of the Prius times the initial velocity in the y of the Prius all over the mass of the Durango and the Prius. Okay, this is the information we have right now. So the mass of the Prius is giving us 2954 kilograms. The mass of the Prius is, we forgot to have, this is 2954.54 or 0.55 kilograms. So that's the mass of the Durango. That's the Durango. Okay, so let's not confuse it with the Prius. The mass of the Prius is 1382.73. So this is 1382.73 kilograms times the velocity of the Prius in the y direction is given as 22.35 meters per second. And then we want to add these two masses together. So we have the Durango is 2954.55 kilograms plus the 1382.73 kilograms. That's the Prius. We're adding them together. And then we're taking advantage of all the space, so we get 1,382.73 kilograms, all of 2954.55 plus 1382.73. This is 4337.28 kilograms. There's a lot of arithmetic going on here. 22.35 meters per second. Okay, and this is just the final velocity. So the final velocity of the Durango and the Prius in the y direction is going to be, that's in the y direction, not the whole final velocity. So you have to remember that. So 1382.73 divided by 4337.28, and then times 22.35. So this is 7.125 meters per second. In the next page, we're going to elaborate what's going on here. So our target is to get, this is our target. This is our target. We have that component, velocity of the Durango and the Prius final in the y is given us 7.125 meters per second. And then we have this component, which is the actual final velocity of the Prius and the Durango that we're looking for. This is 39 degrees. This component in the x direction is, that's going to be in the next part. But this is the information we have. Remember that the final velocity of the Durango and the Prius in the y direction is the same as the final velocity of the Durango and the Prius times sine of theta. So if you want to get the final velocity of the Durango and the Prius, you have to take final velocity of the Durango and the Prius in the y divided by sine of theta. So this is 7.125 meters per second. We divide that by sine of theta. Theta is 39 degrees. And so we end up having divided by sine of 39, and that gives us 11.322. So that's the answer for part B. Okay, so the final velocity of the Durango and the Prius together is given as 11.32 meters per second. Okay, 11.32 meters per second. The other requirement of the problem was to get the initial velocity of the Durango in the x. Okay, the initial velocity of the Durango in the x direction. So we're again using the law of conservation of momentum. And since now we already have the final velocity, it's really easier for us. So the initial momentum of the Prius in the x plus the initial momentum of the Durango in the x equals to the final momentum of the Durango and the Prius in the x direction. And this turns out to be the mass of the Prius times the initial velocity of the Prius in the x direction plus the mass of the Durango times the initial velocity of the Durango in the x direction. And then we combine the masses, the Durango and the Prius, and then we get the final velocity of both of them in the x direction. Our life is going to be easier because we do have the initial velocity of the Prius in the x is 0. So this is just going to be 0. Our target is to get the initial velocity of the Durango in the x, which is exactly the same as the actual initial velocity or the velocity before it collides. So then velocity of the Durango in the x is mass of the Durango and the Prius times the final velocity of the Durango and the Prius in the x divided by the mass of the Durango. So in the next page, we're going to be finalizing our problem. Initial velocity of the Prius, or rather Durango in the x, equals to the total masses. And at some point, we're able to get the total masses right here, 4,337.28. 4,337.28 kilograms times the velocity of the Durango and the Prius, the final velocity, cosine theta. This one is the same as velocity of the Durango and the Prius, the final in the x. Okay, that's what this whole thing is equivalent to. And then we divide that by we divide that by the mass of the Durango. And the mass of the Durango is 2954.55. So 2954.55 kilograms. And so this is 4337.28 kilograms times 11.32 meters per second. 11.32 meters per second. That's the final velocity of the Durango and the Prius, times cosine of 39 degrees, and then we're dividing that by 2954.55 kilograms. 4337.28 divided by 2954.55 times 11.32 times cosine of 39. Such a long problem, but we're almost there. We're getting to the initial velocity of the Durango before collision, and that initial velocity of the Durango before collision is the same as the initial velocity of the Durango in the x, and it gives us 12.92 meters per second. This is part A, requirement. Hope you enjoyed the problem. Feel free to send any questions or comments. There were two parts to this problem. The first part was to get the final velocity of the Durango and the Prius, which is this, even though we flipped it. And then we were able to use the law of conservation of momentum in the y direction and the sine of the angle theta, which is 39 degrees. And then we were able to get the final velocity of the Durango and the Prius. Using that and the law of conservation of momentum in the x, we're able to get the initial velocity of the Durango in the x direction, which is exactly the same as the initial velocity of the Durango. Send any questions or comments and have a wonderful day. Okay, thanks, bye.